Warm-up problem from today's class. Get this cleaned up a little bit. So yeah, it's a hypothetical situation that we discussed. If you had a job as a quality control inspector and you sample the output from two machines that were producing bolts to a certain standard, and you selected 5 from machine 1 and 5 from machine 2, and then you measured length, and the required length is 105 millimeters, and so you can see the measurements that were taken, and you can tell this is what two millimeters less than 103, right on it. 1 millimeter less, 2 millimeters over, right on it. And the same with this machine over here. You can tell these are all 1 millimeter over, and this one's right on it. So we use this kind of as a vehicle to have a conversation about the statistics that are in the chapter 7, which is the average, the median, and the mode. Very easy to calculate these we did it for machine 1 and machine 2, but just drop down here for a moment and look at machine 1. The average is sometimes referred to as mean. You'll see it mentioned as mean. Usually they'll say that it's the arithmetic mean, but most of us would probably call it an average. And how do you find that? You just take the data items, add them together, and divide by the number you have. And so the average for the machine 1 was 104.8. The median is the middle value. When you have an odd number of items, as we do here, you can find a naturally occurring median. So how do you do that? Well, you put your data items in order from low to high and then find the middle value. Physically, the physical middle. And in that case, for machine 1, it's 105. And the mode is any value that occurs more often than another. Well, for machine 1, you can tell it was 105. Jump into machine 2, you can tell that 106 was the mode there. Now, the average is often referred to as the center point, and I prefer to refer to it as a balancing point. And the reason for that is because we've already given the median the name as the middle value, and so that kind of implies a center point concept. But remember now, the median is just going to be a value that's either in the set, and if it's an even number of items, we have to do a little averaging. We take the two middle numbers, add them together, and get the average of the two middle numbers. These are all odd numbers of events, so we're just able to find a naturally occurring median here, and over here the naturally occurring median would be 106. The mean is a calculated value, and in this case for machine 1, the mean calculates out to be 104.8. Now you can see the idea of the balancing point if you'll just kind of take a look at the calculation that's down at the bottom here. So here's the data: 103, 104, 105, 105, 107. I put that in order to do the median. The mean is a calculated value of 104.8. If you look at the distance from the values that are below the mean to the values that are above the mean. So notice the 103 is 1.8 units below. 104 is 0.8 units below. Add those two together and you get 2.6. On the other side, 105 is 2.2 units above, 105.2 units above, 107, 2.2 units above. Add those together, you get 2.6. These are millimeters, but so notice the sum of the distance of the values that are below the mean equals the sum of the distance of the values that are above the mean. And so if you think of this as a center point, I like center point. It's going to be a calculated center point for the numbers. So these statistics are very easy to calculate. They're pretty straightforward. Now, we did have another conversation about the idea of variation. These statistics don't tell you anything at all about variation. And generally, when we are considering data, we really want to think about variation. And so you can tell we did a little work on that. We said, well, you know, if the standard is 105 or the required is 105, notice this one is This one is 2 units below. This one's on standard, 1 unit below, 2 units above, right on standard. These, on the other hand, they were all consistently 1 unit above, and this one was on it. So the idea was that there's more variation in this data, that is the change of the data from the standard, the 105, the required length, than this one. Now this one is consistently high, and then it hits it. So you can tell that for whatever reason, this machine is consistently producing bolts that are longer. This machine is producing kind of a, hard to say. One time it's longer, one time it's on it. Excuse me, one time shorter on it, shorter, high, long. Yeah, you can tell there's some variation here. So what we did is we said, you can communicate that with a type of chart that's called a process control chart. And so what I did is I said, well, let's pretend that this is the standard. This is the standard we're trying to hit. And so these were the measurements from machine 1. So we had a measurement, original measurement, that was 103, 105, 104, 107, 105. So you can visually see the variation here. Now, what if in fact that while the standard is 105, we would allow items to be either 3 millimeters over or 3 millimeters under. So you can see if you've got a band here that you're trying to control within, this machine, even though it has variation, it stays within that band. On the other hand, if you look at machine 2, same idea. Here's the standard. Here's the sort of the boundary of 3 plus 3 millimeters minus 3 millimeters. So you can tell this machine is very consistent, and then it does get back to the standard. So it seems to me like if you were in charge of this operation, you'd want to say, is there something I can do to this machine so that it's not cutting those bolts slightly too long? That might be an easy fix to get it right on the standard. This one would require a little more effort because it's the variation doesn't give me a pattern that I can really tell much about. So anyhow, just another idea on graphing numbers. Now I think you can see visually that it's easy to tell that this machine has a lot of variation in its output in terms of whether or not it's on standard. This machine also has output that's slightly off standard, but it's very consistent. You think about which problem you'd rather solve, either this problem or this problem. All right, so that's what we did today in class, talking about statistics, average, median, mode, and some conversations about variation.